We're really happy to be here. Vikram is representing Lord Axe Sargent, and Josh and I are from Rocky Mountain Institute. We are deeply involved in the green design world, architecturally trained and practicing both the design of buildings as well as consulting on them to reduce overall architecture, energy impacts, essentially, but all kinds of environmental impacts. So as architects, what is really interesting is that we do all this work in design, and yet what happens? I mean, we're sort of in this position where a lot of the things we've designed are not really completely what we expected to have happen. We wanted flat screen TVs, and we got pollution in Lake Michigan. We wanted to have great places to live, and we ended up having all kinds of various environmental destruction. So we're now faced with a bit of a conundrum, which is how can we reconcile our Promethean inventiveness, our ability to really solve problems with the problems that we are now facing, and how do we actually do that? And it's our sort of contention that SketchUp and environmental design issues in general are things that we can address as long as we take our focus and we put it to that. Many of you may have seen this graph. This is a graph that Edward Mazzaria put together, basically showing, and it's the same data is available in lots of other places. Business as usual results in steadily increasing CO2 levels. Since I've been on this planet, they've gone up about 75 parts per million every year. The amount of CO2 in our atmosphere continues to increase. And yeah, so obviously, there you go. He's always good at assigning me blame for most of this. But I think you've got pretty big carbon footprints there yourself. So. But the good news about all of this is there actually is a possibility that we can do something about it. And that's really what our job is today, is to try and be sort of creative about addressing this. And in many ways, I think the things that we have to do in order to address climate change through the building sector is not rocket science. It's not all that difficult. When I think about trying to get my kids to go off to school in the morning and get them dressed and in the car and that kind of stuff, that is really hard. Getting buildings to use less energy is really something that we're trained to do and that we can do pretty easily. So we need to turn it around. We basically need to go from this point now. Now we need to start really designing buildings that have 50% less energy consumption. We need to get to a point where we actually take our designs and make them responsible and work towards getting to a global climate target that is acceptable. Now, we can debate exactly what that is, but we know we need to turn the ship, and actually, as designers, we have that within our power to do. So, the good news, again, buildings actually use a lot of energy. Even when you account for materials and so forth, it can be up to 50% or more energy than the other sectors, transportation and industry and so forth. And what this means is there's a big opportunity for us. Buildings are also the solution to a lot of this problem. And as the people in the building industry here, we have that opportunity to really engage in that. So the way that we would sort of suggest you doing this is through the creative aspects of design. We have to look at what is handed to us climatically and as other patterns, and how can we actually engage buildings to do that? Look at what's going on around us. What are our solar resources, our wind resources, the different bioclimatic design things? Use those as ways of thinking about design, and then integrate it so that we can reduce our overall environmental footprint. And that's what we're here to show you today, is a bunch of small tools that can help you do that. We believe that these are things that happen early in the design process, to the degree that we can start out right up front, getting a good orientation for your building, getting good shading, understanding the carbon implications, doing good daylighting, all of those things, all of those big ticket items, we can go ahead and actually make them less of a problem. We can basically reduce the scope of the issue and get to where we want to get to. So Vikram will talk about Chaya, which is a shading tool. Josh will talk about daylighting. I'll talk about Greenfoot, which is an ecological footprint tool. And Peter will talk about the design, energy design plugin as well. We're going to use this little model, this beautiful SketchUp model that we made specifically for this, which is a case study office building that we located here. It's just a 40 by 80 foot floor plate. It's got about 12,000 square feet on 4 floors. We located it here in town. And a typical office like this, it would not be unusual for it to run in the range of about 90 kBTU per square foot per year. Now, I realize a lot of you may not be engineers here, but that top number there on this chart, you guys can see the 91 up there, because I don't think I can reach it. That 91 refers to the energy use intensity on the site. So that's how much energy a typical building might use in a year per square foot. Well, what we need to do is we need to drive that down. If we get to this first box, that's kind of typical code, 90.199, that's about 53 kBTU per square foot. If we go further, then we get to the sort of CBEX average, and that's the 50% goal that we need to get to now. So that's where you should start today. But what we really want to do is, of course, drive it down even further, if we can, to getting to these sort of net zero carbon buildings, or maybe even further down into energy positive buildings. And there's certainly many examples of buildings that have been done today that either totally reduce their carbon footprint or actually produce more energy than they consume. Those of you who are architects with the AIA and perhaps have looked at the top 10 green buildings that are done every year, and there have been several that have produced more energy than they consume. This is not, again, rocket science. I'd rather be doing that than trying to get my kids off to school in the morning. Okay. So there's a pretty easy way to go about this. And again, we're not trying to diminish the significance of this, because otherwise everybody would be doing it already. But what we're trying to do is say the straightaway way to do it is to reduce the scope of the problem, basically through design. And that's where SketchUp comes in, because we can make a lot of these design iterations pretty early and understand what those things are. So daylighting, efficient mechanical systems, efficient fixtures, different kinds of issues relating to orientation and insulation. Those things to basically just reduce how much energy your building is going to need. You need to do an appropriate analysis to see what are the specific issues that for your building might be most important. Sometimes it's lighting, and sometimes it's ventilation. Different buildings in different locations have different energy use patterns. But basically, just through design, we feel that you can get usually to that 50% mark pretty quickly. The second place to go is to add renewable energy technologies, different kinds of low-carbon sources of energy, PV, as we have here, solar hot water, et cetera. So different ways of basically providing energy to make up and displace all that energy that's right now being generated by coal-burning power plants and so forth. The third way of doing this is through offsets, different kinds of either utility-generated clean power. That's a very reasonable way of going about trying to get to a low-carbon diet for your building. But again, it's the abundance by design. It's going right up front. This is the way that you can actually get the most bang for your buck. We see that this is kind of done cost-effectively. Usually, we can reduce capital costs right up front by just designing the building well to begin with. So with that, I'll turn it over to Vikram, who will talk a little bit about this tool.
Okay. No, I'll just speak from here. So Chaya is the name of the tool for those of you who are wondering why I chose this random name. It's actually derived from Indian mythology. Chaya was the mistress of the sun, the goddess of shadow, and this started off as a shading tool, so that's where it comes from. The premise is that generally the way we interact as architects with engineers is linear. We design a building, hand it over to them, they design the systems, and by the time it comes back, all the good decisions have been made. So the idea is to get in early and have meaningful conversations back and forth. And the question is normally one of efficiency. How many seals can I get out of my system? And the real question that we should be asking is, how often can I shut my systems off? Can I make my buildings drive less, for instance? And design teams are generally very passive about the passive approach. So they really don't want to, design a building that operates without systems, because God forbid we can't, turn the thermostat up or down by 1 degree. And then some of the initial concepts are, very simple. Shading is needed when the building moves from the heating season to the cooling season. Duh. The current methods for building simulation for shading optimization are iterative, which is very tedious. You do a simulation, you check, okay, 1 foot, 2 feet, 3 feet, how big do my shades need to be? And there's always a time lag. And the second one is most popular, it's guesswork. Oh, it's about 2 feet, So, so if you will, for a minute, just imagine a matrix that on the x-axis has the months of the year, and on the y-axis you have the hours of the day, representing a daily cycle and an annual cycle. So you can actually get a true representation of an entire year with a matrix like this. And if you could draw a line across that matrix that kind of represents when your building moves from heating mode, which is represented by blue, to cooling mode. And if you could convert that to your building and say, okay, that's where the sun is at that point, you'd know what your shades need to do. So if you could convert that to sun angle, that's... So the question is, how do you define the overheated period? The factors that, and I'm going to rush through this because we don't really have much time, but the factors that affect the building thermodynamics are radiation, plug loads, lights, people, all of that stuff. And balance point temperature kind of represents all of these factors together. And for those of you who are not familiar with these aspects, I apologize, we don't have time. But there is a paper that's on my website that you can download that explains these factors. So this actually comes up with a shading coefficient matrix as well that actually calculates your shades. And what I'll do right now is I'll actually go over to the demonstration over here. And right now it's Microsoft Excel based, and I'm hoping one of you Ruby scripters over here want to collaborate with us, because it would be really cool to actually have it in Ruby script. But essentially what this does is you've got these sections of different of your west window, south window, and stuff like that. And you can see over here it's starting to overheat in this period of the year, which is kind of towards the afternoon, towards the late end of the day. So you can see over here, the minute I start to add windows, window shades, how that period disappears. And this gives you instantaneous feedback. So it's actually calculating real time what your building is doing, what those shades do. And this little line over here, this graph over here on this side, actually calculates tonnage on your HVAC equipment from your windows. So you can real time see what adding shades does to your HVAC loads as well. The other thing it allows you to do, for instance, is, right now this is based in San Jose, so it's relatively mild. But right now the building is elongated along the facing east and west. So if I change that around and make it, essentially you can actually rotate your building, and it actually gives you the difference. And what this was intended to demonstrate is that by a simple rotation, you actually move that red period towards the winter months, and so you can track real time what's happening. The other thing it allows you to do is change your window sizes and stuff like that. I probably have to sign off now, but essentially you can download this on the website, and at the end we give the web address and play around with it. I'd love to get feedback. Thanks.
And we will have some questions and time for questions too.
Vikram talked a little bit about Chaya, and I'm going to talk about sort of this process that designers can go through to do really good daylighting design. And what does it end up getting us? So I'll start with Google SketchUp, then AGI 32, and then a little bit about this program called Spot. Chaya it outputs really useful information that we can put directly into SketchUp, and it will help us design overhangs like he had shown, or other exterior devices, or can start to help designers understand how it's affecting the building, the heat gain, and other aspects. So to go a little bit further into why have good daylighting? Well, first off, it prevents glare for occupants inside the space. It reduces heat gain, it reduces the cooling load, and it reduces the time needed when there's electrical lights. So you can have just really nice lighting in the space and have it with daylighting, you have light that fluctuates, so it's actually more comfortable for occupants, and they can see their work a little bit better. This is that building that Victor had shown earlier of that typical commercial building oriented correctly east and west. This would be like a pretty typical overhang that has both glare cutoff angle and a heat gain cutoff angle. And the Chaya is outputting the heat gain cutoff angle. And then what SketchUp is awesome about is that it really helps us understand where there are glare issues and how often glare is going to come into the building. So you can size interior light shelves and other things to prevent glare. So there's the base case on the left and then the shaded one on the right. And in a little bit, it will show that without the shading, there's going to be glare throughout the day from the east and the south. And then with the proper shading on the right side, there's less glare from the east, and then now the sun is actually just hitting the exterior light shelf and also the interior light shelf to start bouncing the light. But SketchUp doesn't do a very good job of showing that extra bounce and how the space is going to actually feel like. So this is when we start to go deeper and go into AGI 32, which is a 3D modeling tool that we can actually import SketchUp models directly. So we take simple SketchUp model, and usually we'll just deal with like one floor, and it can give us quick renderings of what the light is actually doing to the space. So in this case, now that we have good lighting, you can see that there's balanced light levels. The light is starting to bounce off of the light shelves onto the ceiling. So you can start to understand where there might be dark spots and other things that are happening within the space. Then we can take that model and get a little some outputs from AGI 32 and see what's going on and see whether the light is actually satisfactory. So it graphs it in sort of a false color rendering, so you can see like foot candle levels and contrast. So like on the top one where it's unshaded, we have these bright spots, and then you can, once you actually go in and see the rendering, you'll understand that it feels really dark even though you have lots of light. And then on the bottom, it's much more even, balanced light levels, and you can actually have lower light levels, but it actually feels comfortable. After we understand the light levels, now we know that there is enough light in the space. And so we now want to go a step further and say, okay, what will this do? Why is this beneficial? Well, we want to end up trying to turn off the lights as much as possible. It'll save us money. It'll have pollution avoided. There's energy reduction. And so what we can do is plug it into this little tool called Spot, and it gives you a generic. You can do a generic layout of the electrical lighting fixtures, and then it will determine how often these lights will be turned on throughout the year. So it really looks at how much daylight it's getting into the building, and saying, okay, the middle spaces and the fixtures are going to be on maybe 50% of the time, and the ones in the front are going to be on are not going to be on when there is daylight availability. And so what this does is it gives us an output of each day and how often the lights are turned on in that space. So if this is for the space that's really well shaded, it has thin floor plates so we can get bilateral illumination, and as you can see that it's really taking advantage of all the daylit hours, and the lights are only on about 11% of the time. And what it does is you can plug in this program when the occupants are going to be occupying the space. So it's probably like 15% because there's hours of the day when the lights have to be on when there's not daylight. And in conclusion, I just wanted to just reiterate that we're trying to get to the point where we can really show how we can actually start to turn off the electric lights and reduce the cooling load and really understand the heat gain implications of the building. And all three of these tools can really be integrated, and SketchUp is a really important aspect of daylight in design.
Josh ends up doing a lot of our daylight modeling at RMI, so it's really, he knows these things inside out. We're going to talk about one last little small program, spreadsheet, which we produce, which is Greenfoot. And what this is a tool to basically do environmental footprinting of your building. So we can measure all different metrics, water use, et cetera, and sort of see how your building kind of adds up. For those of you who aren't familiar with the concept of an ecological footprint, it basically says that we have lots of different end uses for different kinds of needs. We use ecosystem services to produce fuel for, building on our planet. We use it for absorbing CO2 for all kinds of different material production. And then we only got one planet. Even though we showed 2 globes earlier, we really only have one planet. And the question really is how much of that are we using? How do we reduce our footprint in order to kind of work within the means that we have? What we've done is we've kind of taken that and adapted it to buildings, where we really look at what are the main building impacts, water and energy and CO2 and so forth, and we associate that with the productivity of land, water, and ability to assimilate, and we've then basically put this into a simple little spreadsheet. So let me give you a quick demo of that. Let's see. And this, of course, will crash as well. Okay. So we have a couple versions of this, but this is, again, a very simple set of spreadsheets that show, in this case, really the CO2 impacts. When you take this, you can kind of click through it, and you can say, is your building, has the energy use been modeled? Or you can use sort of regular, the CBEX data is the data I referred to early on, kind of standard kind of Energy Star type building data. So you can either enter that or whatever. We'll say use CBEX data. Does the building have on-site energy production? So do you have wind power or PV or something else? You can either put that in, or you can choose there. And the same thing for where your electricity is coming from. Do you want to put in your own blend if you know that all your electricity is coming from a certain place, or you can actually plug in your state, and then it'll use an average blend for that state. And so here you just put in the basic size of the building, and in this case, since it's the CBEX data set, you could say, you're going to use an outpatient facility, or in this case, an office building. And different kinds of uses in the building would be there. And plug in what you think your savings might be, if it's going to be 50% or whatever you'd like it to be, whatever you hope it. Well, if you model the building, then you would plug in that. Or if it's a goal, if you say you decide, my goal is to make it 50% better, you would plug that in. So you can either use a different energy model, or you can get the data through something else, or use it as a goal-setting device. And then similarly, here you'd plug in your state. So if you're in Pennsylvania, it'd be PA, and so forth. And so you've got different blends. And here you can see in Pennsylvania, they have a lot of coal. In California, I think you do quite a bit better. Not so much coal, mostly natural gas. So you've got a fairly low carbon sources here, which is nice. So you continue through, and then at the end here, there's the kind of final sheet, which says our building, for this, our little office building in California, has a base carbon emissions of about 70 metric tons a year. And if we get to sort of this 58% CO2 reduction, then that's more like 30 tons. And That means in terms of the amount of land used to do that, it would be about 11 acres of land on an annual basis would be required to sequester that amount of CO2. Or you could turn it into how much you would need to spend on renewable energy certificates or some kind of offsets if you'd rather do something like that. So that's kind of what it does. It's a real quick, simple spreadsheet that gives you an idea of how much impact your building is having on the environment. We also have an expanded version of this that we're not going to go into, but that goes into water in great detail and energy production as well as other things. Oh, and just one more thing about that is we put it together with these different kind of design sliders. So again, like the tool which Vikram showed with these little slider bars, a lot of this stuff is kind of that push-pull SketchUp idea of iteration. It should be kind of a dashboard that you actually can just jump right into and use at a preliminary design stage to say, we think that this is a good way of working. And this is kind of where we're hoping to go with this, is to produce some kind of little plugins that basically have the green foot or lighting or water or the Chaya shading analysis as part of that, so that we can actually more seamlessly integrate this with this iterative design process, which is so great, such a great part of SketchUp and why we think it's so powerful to get this stuff done early. So a lot of these things are available as mentioned. There's a website up for Chaya and for Greenfoot, and Spot is also available for free. AGI does cost money, but again, that's available and a pretty powerful tool. In conclusion, then, I would just say that this is really an opportunity. For those of us here in the design professions, we have a responsibility to get engaged in this, and I would encourage all of you to make those carbon reduction goals serious goals for your company. We've recently adopted the 2030 protocol to say that we're not going to design any buildings or work with clients that don't step up to the plate and say 50% carbon reduction is the base. We can do better than that, but at least get to that point. So some buildings are easier than others. Office buildings are easier than perhaps laboratory buildings, but make a stand and actually take responsibility for the stuff that we're doing. Not only is it increasing the value of your project, it's great for the planet, it's going to be profitable for you, I guarantee it, and of course it's good for all of us in the larger social sphere. So get at that triple bottom line, go for it. It's really, I think, the challenge of our lifetime. So thank you, and with that I'll turn it over to Peter. Oh, you can need to switch out your computer, so if we have a couple quick questions here, I think that'd be a good time for that.
You were talking about modeling the building. Is there any way you can model it in SketchUp and bring it into some of these programs, or does that have to be done in something like Revit or AutoCAD or something like that?
Right now, currently there's AGI 32 does a pretty good job of importing DWGs directly from SketchUp, as long as you know how to name the layers and give them certain characteristics. And that actually works really well. You can get a really nice model. You can start to do curves and other interesting things. Spot, unfortunately, it's fairly rectilinear. You have to build your own model in their platform. Hopefully they'll come out with a version that you can import DWGs, but currently it's very limited. And then the other one is Spot Spot I talked about a little bit. And
yeah,
go ahead.
Add one. We actually did. We actually just finished construction on a project where we did CFD analysis, and for those of you who don't know what that is, it's computational fluid dynamics, and it's pretty advanced energy simulation. And we did that straight. We exported the SketchUp model straight into the CFD program for that one.
I haven't personally, but I believe Victor has.
I was trying to sneak over there. Yeah, we've used Radiance and Lumen Designer and several other programs as well. There's Ecotect is out there. There's a bunch of good programs, and I think our main concern is trying to get all those things to be used up front. So we are oftentimes in this position of having to kind of do remedial work on a design, and if we can actually do some of these analyses right up front, like SketchUp allows us to, then that's great. So to the degree that we can get something like AGI to read the file directly, or even the plugin that Peter's going to talk about, that really helps us get that information when we can really make strong changes. Got one question back here, and then maybe one more, and then we'll go to Peter's presentation.
How far out do you think it is till SketchUp starts to pull these scripts that you alluded to it with the little like signs going down, but I mean, how far out do we think some of these tools are?
How many of you guys do Ruby programming? Okay, so talk to them.
Right, so I'm going to repeat the question just for the videotape, which is how far out are we for actually seeing this stuff happening instead of just sort of showing a little mock-up of a screen. And some of it, like the AGI stuff, we can do right away. Some of it is really as simple as getting somebody to write a quick script that links the Excel spreadsheet or the Python or whatever to it. And some of it is probably farther down the road. But I would actually venture that that's probably something we can discuss more here, and also probably for SketchUp in general to talk about, as well as us as users. If it's okay, I'd like to make sure that Peter gets enough time, and then we'll take a couple questions at the end, 'cause hopefully we'll have a few minutes. Thanks. You ready?
Yep. Okay, thanks, guys. That's actually a really good setup, everything they were talking about for sort of an overview of what we're trying to also do with the energy design plugin. This is actually something that already exists for SketchUp as a plugin. And what I want to do here is give you a few slides in the beginning to give you an overview of what it does and where we're going with it, and then spend a lot of time doing more live demo stuff in SketchUp. Let's see. And apologies that you have to see the edge of my PowerPoint stuff here, technical difficulties. So. Okay, let's get going. So the Energy Design plugin is actually an interface for Energy Plus, which is a whole building energy simulation engine. It's a program that's sponsored by the Department of Energy. It's the thing about it is it's a simulation engine only. So that means it doesn't have a good graphical user interface. You basically have to work with it with text files, and it's very difficult to work with. It's almost like programming. The good thing about Energy Plus is that it offers a lot of state-of-the-art capabilities, a lot of the best new models for different systems and components that are out there these days for high-performance buildings. You're actually able to model those fairly well in Energy Plus. It has continued funding from DOE, and it's a free program, so you can download it from the Energy Plus website at energyplus.gov. So what the Energy Design plugin aims to do is to add Energy Plus functionality to the SketchUp 3D environment. Basically, initially, our main goals are to be able to create and edit an Energy Plus input file, run Energy Plus from within SketchUp, and view the results without leaving SketchUp. And then for version 1.0, we will be able to automatically create building models using a web service that I'll talk a little bit about, but mostly we'll focus on the rest of the stuff that it does today. So the plugin was designed by me at NREL, which is the National Renewable Energy Lab. Our first beta release went out on April 1st. You can download it for free at energyplus.gov. It works with both the free or the pro version of SketchUp. And right now it's only available for the Windows version, but we will have a Mac version later. There's just a couple technical things to work through. So we think that the plugin really could be a key to integrating simulation into the early phases of the design process. Victor and Vikram and Josh, I think, emphasized that point that early is better. I'm just going to elaborate on that a little bit more here. Our experience with working on real building projects, real high-performance projects at NREL, we've done a number of case studies, is that the form decisions that are made during the early phases of the project, of the design process, can have a really big impact on the overall energy performance of the building. So ideally, if you can do simulation during the early phases, that can help optimize the energy performance without actually adding to the cost of design. Unfortunately, traditionally, simulation is something that happens at the end of the design process, usually just to model the HVAC options, to do system sizing, and maybe for code compliance or lead points. So this is kind of where simulation happens most of the time right now. Here's the design process. And what we'd like to see is that simulation moves here, where you can actually have a big impact. You know, because once you get into this stage here, you're already in the CAD phase, and it's usually much too late to make big changes to the form, you know, such as adding or changing the orientation of the building, or adding and removing windows, changing the massing, things like that. What, yeah? So probably many of you know this better than me, but this is how SketchUp, or how I've heard SketchUp is used in the design process. It's often used by architects during the conceptual phase to quickly create a building form and massing, present that design concept to the client, and then maybe based on the client's feedback, iterate on that a couple times until they settle on a final design concept. And then from there, development moves into the CAD stages. So what we'd like to see with the plugin is that you actually get simulation starting to happen here before the design ever gets to the client. In version 1.0 of the plugin, which we're not at yet, right now we're at version 0.9.4, which is still a beta. Version 1.0, our main goal is really to make entering the geometry for Energy Plus easy, which traditionally, I mean, in the past has been pretty difficult with Energy Plus. We also will have this ability to automatically create prototype and compliance models based on what you've drawn in SketchUp. And that's going to be a very powerful feature. It's using a web service that we have, which runs currently right now as the Energy Plus example file generator. And you can get to that through energyplus.gov as well. It's just a couple of web forms which will automatically create a file for you and then email you the final file and email you the results of that simulation. So the target audience for version 1.0 is pretty much current Energy Plus users, or possibly prospective Energy Plus users that were thinking about using Energy Plus, but might have been put off by the problem of entering the 3D geometry. Another interesting thing about 1.0 is that it's actually an open source project. Right now, the beta is out there under an open source license, so when you download it, you'll have all the source code for the plugin. Our hope here is to gradually build a developer community and sort of have the plugin take on a life of its own, so that it won't be just me developing it all the time. So the audience for that is, you know, developers in industry, maybe people who are doing developing software for building simulation right now, but also SketchUp developers, RubyScript programmers, enthusiasts, and any other collaborator. For version 2.0, we want to be able to add more and more of the inputs that you need to create a complete Energy Plus input file. That audience still is pretty much going to be simulation experts and possibly brave architects. And then finally, the ultimate goal, the end goal, is to get to the point where we have simulation for everyone, which kind of borrows from SketchUp's mantra of 3D for everyone. So this would be, you know, given an appeal similar to Energy 10, you know, something that engineers, you know, non-simulation experts, architects, even homeowners could potentially start using the plugin to do meaningful energy simulation. So as an open source project, there's a lot of exciting possibilities for adding other things to the plugin besides just sort of Energy Plus focused functionality. You know, perhaps we could sort of build Chaya into the plugin as an option, or the green foot analysis. Some other exciting ideas might be to do life cycle analysis or photorealistic rendering. The thing is that in Energy Plus, we already have a lot of the properties that you'd need for that. The surface reflectances, the surface, a lot of things about the constructions and materials that go into the building. So I see a lot of opportunity there. And I think this is my last slide before we get to the demo. We see the plugin really as hopefully a key to bringing energy simulation into the early phases of the design process before you get to CAD or the architectural drawings. It could bridge the gap between simulation tools and the design process, and it's also, for us, it's a good demonstration that you can leverage an existing software tool to add energy functionality without having to rewrite, reinvent the wheel, write our own 3D geometry interface. And SketchUp, does a fantastic job of that for us already. So I think we can get on to the demo part. Okay, here we are in SketchUp. What you might notice right away is that there's a few toolbars that the plugin adds. And all those toolbar buttons correspond to a special plugin menu. These are all the plugin commands that you get. And so let's say I'm starting off creating a brand new model. I'm going to start just drawing a building. So the first thing you need to do is create a zone. You click that, and what I've done is basically just created an empty group in SketchUp. It's kind of neat to present to you, because usually when I'm presenting, I have to explain SketchUp and explain, oh, what is this, and all the benefits of SketchUp. You guys already know that, so it's a great help for me. So once we get inside the group and start drawing stuff, you'll see that things look a little different than you might be used to when you're usually working just straight with SketchUp. So what's going on here is, as you're drawing in this group, the plugin is watching your every move and basically creating Energy Plus objects simultaneously as you're drawing. So that's why you see things in different colors than you're used to. So, and I'm obviously showing off my amazing SketchUp skills. So now, just to prove it to you that there's actually Energy Plus stuff behind what you see here, we can go in and start clicking on things and open up this handy guy. This is the object info window, which is going to show up on my other screen here, and I bring it in. And I understand you don't want to really know what all this means, but basically each of these, in Energy Plus, it's kind of structured around objects. So let's say a wall has its own object, a window has its own object. And what you're seeing here is the inputs that go into creating an object for Energy Plus. And this bit down here is the actual text that the plugin has written to the Energy Plus input file. This is the stuff that you used to have to do by hand to describe your building. So imagine putting in all these 3D coordinates manually. You get really good thinking in 3D, but it's a real pain. So you can switch things, like change the boundary conditions, like say this one has no sun exposure, no wind exposure. You can select the construction. Let's see, it's a heavy exterior wall. And as you make those changes, it's dynamically updating all of the text down here. And you've got a nice little summary in this area of a few handy things to know. So if we click on something else, let's say this window, it's got a slightly different set of inputs that Energy Plus requires, and you can set those here. You can pick things like the shading device, frame and divider. We'll just set the construction. Unfortunately, right now in the plugin, you have to sort of you'd have to have pre-configured your shading devices and frames and dividers and constructions beforehand. So the plugin doesn't handle that yet. Yes? Question?
Does it use the SketchUp's location system?
the question, yeah, the question is, does it use the SketchUp location system? And the answer is yes. It's synced with the, actually I shouldn't, oh, is that the right place? Yeah. That is in the simulation info. So you see here, it's got the latitude, longitude, time zone, elevation. So if you went in and changed that through, let's see, I think it's model info. If you changed it here, I'm not sure it's going to do it dynamically. If you change it here, then if you go in, now it's updated that. And it works two ways. So if you changed anything here, it's going to update the location.
For other countries?
Yeah, I think so. Yeah, it's just doing latitude and longitude. The only thing it can't do right now is the elevation, because SketchUp just doesn't carry that information right now. Yes.
Do you model other buildings that are adjacent to it for some shading?
Yeah, that's, you can do that with, so this was a zone group. To do shading, you'd create a shading group. And it's pretty similar. It's got a different color. And now those are all created as shading surfaces.
If you're designing inside an existing cityscape that's already modeled in SketchUp, can
Yes.
you use that, or do you have to put all those buildings into the group for shading?
Right. The question is, if you have an existing cityscape or existing buildings in your model, can you use those for the shading, right? What you would do for that is basically trace over them. So you can have them in your SketchUp model, and then you'd add a group like this, and it'll still snap to the same points in the SketchUp model, and you just sort of trace over there. So typically, you don't want all that detail that you'd have anyway of all the other stuff in there. So this would sort of let you simplify things, and yeah. Let me try to go on farther before we do too many questions here in the middle, okay? Let's see. So where was I? So one thing I want to point out with this is that I've gone to great lengths to sort of make the plugin experience pretty much seamless with the rest of your SketchUp experience. You can just sort of draw as you normally would without selecting too many special tools and doing anything sort of out of the ordinary of the usual, happy SketchUp experience. Let me close this one. And I want to show you that it can also read in existing Energy Plus input files. And that'll show you some nicer geometry. And the plugin comes with, oops, not those examples. The plugin comes with its own examples. So let's see, what's a good one? So you can't see it because it's drawing on my screen. So it's reading in the input file, parsing it. And depending how big your file, it might take a little bit of time. So now it's drawing the full model. And this was a building we studied. It's the Chesapeake Bay Foundation building in Maryland. And so it's got a lot of nice stuff. It's got these are PV panels here. It's got a lot of shading devices. So just like when I drew the other model, you can select these different objects and see, oh, okay, this is that zone. This is that zone. Go inside it, look at the individual surfaces. So let's close that. This is actually a model that we created using the Energy Plus example file generator. So this is an example of the type of thing you'll be able to automatically create using a set of wizard screens inside the plugin, and then using the web service to communicate to our server to create this file. So it's going to be pretty powerful. So this, as it is like this, once you get that file downloaded, it will be basically a complete and fully runnable Energy Plus input file. And at least it's a good starting point a lot of times. So you might automatically create this model and then start playing with it in SketchUp, change the geometry. You could basically do whatever you wanted to editing at this point. Let's see. It's an interesting, this one's got a little bug in it, but it's a kind of more interesting geometry. This is a real project we're working on. I think that's in Greensburg. Is that? Oops. All right, this is just one of our really simple example files. Kind of silly. But I just want to demonstrate how you can run Energy Plus inside SketchUp. So this is the run dialog. You can browse to select a weather file. Here's San Jose. Gives you a bunch of information about that weather file. Let's not do an annual simulation. That can take a while. We'll just do a week. And select a couple things. These are just options for what kind of output it's going to show you and when it does the run. Now you get to see, this is what Energy Plus actually looks like when it's running. So it's pretty glamorous. And it pops up, here's the error file. So it completed successfully. That's good news. And over here on my screen, we've got popped up the Excel spreadsheet. These are the results from that simulation it just did. And I don't know what we're just reporting out. OK, here's electric lights, energy consumption. Those are just kind of unimportant variables that happen to be in the file at the time. And you also get this HTML page that is called the Annual Building Utility Performance Summary, which gives you things like the total energy that the buildings used over that run period, breakdown by end uses and fuel type, and a bunch of other stuff. So those are kind of the standard outputs you get from Energy Plus. Let me close this. All right, this is not a spaceship, it's a building. So one of the neat things that you can do with this plugin, and this is actually an undocumented feature right now. What I've seen as one of the real strengths of SketchUp is it's the opportunity to do really powerful visualization. So after you've run one of these files, you can get the output data in raw form. That's the ESO file. So we just hit open. It takes a little while to do that, to parse that right now, because it's kind of a big file, and I haven't really optimized it yet. So this takes about a minute. It's usually the longest minute of my life when I'm presenting it. But the idea here is that you read in the output data from what you've just simulated with Energy Plus, and as this might hint here, you can actually map the output variables that you've asked for to the surfaces of your model. So you can get sort of a false color rendering of whatever data you want to see on your surfaces. And in this case, we're just going to look at the surface outside temperature, because that's a real intuitive, easy one to look at.
And that's for a single day?
It can be for the entire year.
It's a point in time, or
it will explain itself in a second here. Yeah, this is a really long minute. I think it must be more than a minute. I'm sorry, what?
Is that something
Yes, yeah. We're actually going to have our next release maybe by the end of June. We're hoping to sort of push out these incremental releases every 2 months approximately, with bug fixes and so on, because it is a beta still. Oh yeah, well, royal we. Yes.
What is the schedule for the whole project? I mean, you gave me these different incremental stages.
Yeah.
What's your goal?
It's a little bit hard to say. I'm a little cagey on it because it is going to be it is an open source project. So we sort of have to see where the whole development, if a development community grows around it, and then where they want to take it. In terms of DOE, we only are going to have a certain amount of funding per year, mainly to have me do maintenance on it and maybe add a few small features and keep up with the latest changes in Energy Plus. So we'll have to see how that goes. I think it's still live. Any other question I can answer? Well, Rudy? Yeah. Who was way back there? Yeah. So the question is, what all do you have to put into the model to get an answer, basically? Oh, there it is. I'll just finish this question first. Yeah, so you have to put in the wall constructions, the window glazing types, and the overhangs. So all the geometry part of it. But also a big part, there's also the input for the internal gains, so the people, the lights, the electrical equipment, because that all has an impact on the simulation, of course, too. And then there's a whole other area where you're modeling the HVAC system. You could kind of take that at 2 different levels. You could do something we just call purchased air, which is just basically a load calculation for each space in your building. And that probably is useful by itself. You can use that certainly to optimize the envelope to some degree. But then probably a lot of people will want to take that a step further and model the full HVAC system and different system options and types and so on. So that can be a pretty big undertaking, and we don't have a great solution for that yet. So so after a long time, it finally parsed that file, and these are the different run periods that happen to be in that file. So we had 2 design days, and then 1 run period from May 1st to November 13th. So I'll pick that one. That's fine. Turn that on. Hit OK. Now the other thing I have to do is to flip that switch. And now you're seeing everything with, let me get a little temperature bar here. It's in C right now, so I know that's a little not that helpful, but that'll change. So one gentleman was asking earlier, isn't this a single point in time? And yes, it is, but you can easily change that using the shading sliders. So we can jump around to different times of the year, and you'll see if it goes to white, that means you're outside of the range of results that we have. So we'll stay in here. So there's a spot where it's real hot on the roof. So you can see some pretty interesting stuff here. Now let's take this a step further. You can start animating that. So now it's actually moving. It's changing the time here. We're in the nighttime actually right now. Let's make it double speed. So it's just sort of doing an animation starting from wherever we were in time, marching forward. Maybe we should go to a more interesting time. So you can often see the effect of the sun rising over here. It'll get warm on this side, then get hot on the roof, and then move over to the other side. Does it account for shadows created from geometry? Oh, yes, that's a That's an option in Energy Plus, and that it accounts for self-shading of the building. You can also turn on the shadowing in SketchUp at the same time for kind of a neat effect. So even if you don't want to use the plugin to do energy simulation yet, the animation of the shadowing part might be fun for some of your projects. I don't know.
Well, you have to do something to justify your fee sometimes.
I think I'll cut it off there with the demo, and maybe all of us can answer the rest of your questions you might have in the remaining time. Yes, sir.
You know, one of the exciting things about this in principle is that it's integrated design, that, you know, you get to test this stuff. But the way you've explained it right now, it sounds like I got to build two models. I got to build my SketchUp model for design, and I got to build a completely different model to run Energy Plus.
Right. So the question is, don't you have to build two models? It's kind of like integrated design, but you have to build an Energy Plus model and then your sort of architectural model. And the answer is kind of yes and no. The thought here is that what you draw here in SketchUp, you will ultimately be able to decorate later with SketchUp stuff, so that the two models are the same. The energy stuff would be kind of buried in there, but so if you think of one of these windows here, I could attach a window component on top of that window and make it look more like a window. And part of this is to encourage people to start thinking about the energy model at the same time that they're building. Right, at the same time you're building the architectural model, and it can still look good for the client. There's actually one cool picture I'll bring up. Maybe if you guys have a question for them while I'm finding it.
I was just to elaborate a little bit on that, is that sometimes there are programs like AGI that read in the models directly and that you can that play nicely. But a lot of times you want different information with different models. So the lighting model wants one set of information, the energy model wants another, and there's a certain amount of this sort of, BIM kind of information-rich environment that's useful. But I think at least our main point is that you want to basically just model the stuff you need to know. Because what's this guy's name? Bryce?
Yeah.
He's got to go, right? I mean, we know he's always deleted, and frankly, there's a lot of other stuff that ought to be deleted off your models too for different reasons. Add them back in when you're doing the Photoshop and the presentation, but for the analysis, to a large degree, it's nice to have one environment so you don't have to do a lot of taking off, basically making problems or mistakes with transferring between models, but the model itself should be fairly simple. And we like to do several models. We like to start out early with a schematic model. We might totally redraw it when we get to design development. And of course, SketchUp is not made for doing construction documents, so there's probably another reason to go back and do it again. But in terms of our analysis, there makes sense to kind of try and use it for what it's good for.
The other thing to keep in mind is when you're doing simulation, it's one thing to build the model. The more complex you make it, especially Energy Plus, is really memory intensive, and it takes a lot of simulation time. So what you want to do is you want to simplify the model as much as possible. Sometimes, like with when we do modeling with eQuest in our office, if you have window wall ratio of 40% and there's a number of punched windows, you'll simplify that into one window to make the calculation easier. So.
So here's just one model I wanted to show. This is developed by one of our guys at NREL who's working on a real project and is kind of a beta tester for us on the plugin as well. So he's actually modeling a school building here, and you see he's added a lot of SketchUp components to kind of spice it up and make it look more interesting. But you can see from the colored surfaces that the Energy Plus part of it is still the same. So zoom out a little bit. I think there's a lot of interesting things people will be able to do with that. And later you'll also be able to actually paint these surfaces so that they have a construction texture. They won't be just, one mode will be to view it in these sort of, by surface type. Another mode will be to view it by the texture. So it'll look a lot better at that point too. the question is, will color have an effect on the energy calcs? It can. The color is often related to the thermal absorptance of that surface, and so black surfaces absorb a lot more heat. Light ones tend to reflect heat.
I guess it sounds like the question was, does the color you're actually putting in the
Oh.
model, does it read that?
No, right now the color is just a reflection of what type of surface object it is in Energy Plus. Yeah. Way back there? I'm sorry, could you repeat? What? Green roof data? We don't currently use that. You can do green roofs in Energy Plus. It has a model for that. I'm not that familiar with it, though. Next question.
Are any of these programs sort of developed in conjunction with like the idea of what LEED is doing and some of the movements in design towards standards, things like that? That might maybe you can show like variables that would have to do with LEED things.
So the question is, are any of these tools or programs developed, with an eye on LEED or standards? And for the thing that will automatically create the Energy Plus building models, when it does that, it basically builds a model that meets ASHRAE 90.1, the energy code standard that's common through a lot of the U.S. We don't have anything specifically for LEED right now, but that would be like a great opportunity for someone else to step in and start adding to the plugin those type of capabilities.
Yeah, I'd just like to add a little bit to that. Energy Plus, as a program, actually does have the capabilities of being used to document LEED. Greenfoot and Chaya, however, are not intended to be used ever for LEED documentation. It's basically a schematic, right at the beginning, almost a rule of thumb method of trying to figure out, okay, how can I best optimize my design as quick as possible. So those you can't use for LEED, but Energy Plus you probably could.
One last question. Putting components or wall thicknesses or things like that adjust or change the output information that you're getting. Like then putting shelves or desks or thicknesses in walls, does that change your model?
Yeah. So the question is if putting in components like the desks and chairs or the windows is going to change the actual modeling. And no, it's not going to change the Energy Plus model at all. It's purely decorative. If you wanted to add if you wanted to account for desks or chairs, you'd add that as a thermal mass object independently in Energy Plus.
Probably crash your computer, but.
And I wouldn't. Obviously, with a lighting model, it makes a huge difference how much stuff you have in there. So we oftentimes end up doing more detailed models for daylighting and electric lighting simulations. Okay, one last question in the back. A timeline for the Mac version?
Not specifically. We don't have a timeline for the Mac version exactly, but there's just kind of like one thing we're stuck on. So it could happen like with the next release. It might be 2 releases. Probably by the fall, I would imagine. Pretty surely we'll have the Mac version.
All right, great. Well, thanks for your attention. I think we're now ready for ice cream. Is that right?
Thanks a lot.
Thanks.